Alrighty, so just testing this whole idea out, I figured instead of repeating kind of the same thing over to all my year 10s, I figured I might make a quick video just outlining how to organize and display data, and how to use Excel, which is super helpful, which I've told you all, how to use Excel to calculate things like our averages, our standard deviations, minimums, all this kind of stuff, right? Because we know that in our assignment, we're going to have to prove two things, or we're going to have to do two tasks. The first thing is to prove whether your Year 10 class's data, or I should say your whole of Year 10 Maths Advanced, whether that data for a specific variable, we've all chosen height, which is a good choice. So remember, task 1 is to choose whether, or to prove whether that variable, height, is representative of the national New Zealand height as well for Year 10 kids. That's task 1. Task 2 being to create that mathematical model relating to variables, but we'll focus on that at a later date. So, as I was saying before, I'm just going to run through first of all how to present data, raw data at that actually, in a nice clear way, which is useful for our calculations. So this is what we were given, and obviously it doesn't look very nice, a lot of numbers, you really don't know, what's going on, and there seems to be a lot of blank spaces here and here, and it's just not nice to look at. So what we want to do is organize it so 1, it looks nice, and 2, we can use it and read it efficiently. Also, we note that this is the column we're interested in, all of the height data, but that height data has a corresponding gender attached to it, as well as an age group. Don't really care about the student number, obviously that's arbitrary, not important. And for the task 1, which is that whole determining whether it's representative or not, we only care about one variable. So we're going to ignore these 3 whole data sets down here. So step 1, what I like to do, or what I think you guys should do as well, slash what I kind of already have done for you, is to first of all break it up into age. So I've got all my 14-year-olds, all my 15-year-olds down up to here, so on and so forth for 16 and 17 respectively. The next step I decided to do was to break them up into their genders. This makes these calculations here much nicer, because if you can imagine trying to find the average, you'd have to, for say 15-year-old females with our original data, you'd have to collect this data point, this one, look for all 15, this one, see how it's just like super messy, you don't know which one's a 14 or a 15 female. So long story short, just reinforcing how nice it is to present it in a nice way. We'll also use colour. Colour doesn't hurt. Colour is a helpful thing that we can employ to help us determine, at a quick glance, what data relates to which point. Whether this height is female or male, obviously pink is female, male is blue. So what I'm going to do for the rest of this video, because I don't want to be too long, is to just drag out, or I should say calculate our averages and our standard deviations. All these other bad boys over here, I'm not going to do in this video. I might do them personally with you, but I think they're quite easy. Maximum, median, all that stuff is not too hard to find, but these 2 are the main ones. Also, I've explained to all you guys the importance of not just having a total average or just a gendered average. I've explained how important it is to make sure we have age averages as well as the gender age averages. This will really help our comparison for determining whether 10 Maths Advanced is equal to or is representative of national New Zealand average. Really, so that's our task. Keep that always in mind. So let's just get into some number crunching. The tools I'm going to show you are very useful, not just in maths, but you'll use a lot in other subjects, especially in future. So, quick intro, Excel has many functions that we can use. Average is a very simple one. We all know how to take an average. We sum the values, divide by the number of values, also represented in this fancy formula. But what we're going to do is we're just going to use that to calculate averages. So, and you'll see why this is really nice. What I'm going to do is to invoke a formula. You start with an equal sign. You type what formula you want to use. Nicely enough, the average formula is called average. What we do is we put bracket, open bracket, and what we want to do now is, as I've specified here, is we want to select our data range. So for the total average, I'm going to start my first data point here, and I'm going to select every single data point. Enter. Boom, that's my total average. Height, just remembering that that's in centimeters. Okay, so I'm going to do the exact same thing now, except I want only the male data. So I'm only going to select all the blue data. Hopefully this really lends credibility to how nice it is to have all our data sorted. So I've selected all my data, enter. That's my male average height. So on and so forth. This is going to seem repetitive, but I'd really appreciate it if we could make sure we're paying attention. So, one, we know how to do it on our own, or two, we know how to explain to the teacher that we did it. Right? Enter. Because my tutor did it for me isn't a good answer. So far, in say 30 seconds, we've got our average total height, our average height for the males and females. Now we're going to break it up into the years and the genders. So a lot of repetition, as I said, equals average, open bracket. This is all my 14-year-olds, so it's all this data here. Enter. Equals average. This is going to be all my 15-year-olds. So it starts from the first 15-year-old all the way down to the last 15-year-old. Enter. That's my average there. So I'm going to rush through these and stop talking just so we can make sure this video is not 20 minutes long. It is 10 o'clock and I would like to sleep. So 16-year-olds. I'm just going to start here to here. Yep. Enter. This is equal to average. 17-year-olds now. So only 2 data points. Boom. This is where, again, sorting our data into age and gender is really nice. Because 14-year-old females are all just here. Male 14-year-olds, these ones here. 15-year-old females, so on and so forth. Selecting my data. 15-year-old males. And I want you to be thinking to yourself while you're watching me do this, which is probably mind-numbing for you, but it just, first of all, helps me not having to explain it 5 different times. What the point of all these averages are. Why do I care about the specific averages about the gender and the age group? That's a very good question to be able to answer by yourself, because that's really what you're going to be writing a few hundred words on at the end of the day. So, last average, hallelujah, 17-year-old male, 1 data point, the average is that data point, right? Cool. Just center these nicely. Cool. Save. Always want to save your documents regularly. That's our average data here. What I'm going to do is, see how I've got all these yucky decimal points. I'm going to teach you how to use Excel to round it up really nicely. Select all the cells that you're interested in. Right click, format cells. Go down to number. And 2. So I should press OK. Boom, and it's put them all nicely to 2 decimal places. So, yeah, this is looking nice. There are all our averages. Standard deviation. This one is going to be the same process as what we did up here, except the equation we're typing is going to be different. So S, or standard deviation, is S, T, D, E, F. And what we notice is we have standard deviation P and standard deviation S. This stands for population and sample. We are working with sample, remember? So we have not got everyone's data in the world and all year 10's data, so on and so forth. We've taken a sample, being your class, and a certain region of New Zealand. So sample is the one. Don't worry about the differences there, but it's the same idea. We're going to select our data points. So height, boom, enter. So what I'm going to do is, instead of just going through that boring process again, I'm going to explain quickly what standard deviation is, and then I'll just set a quick picture at the end of this cold box filled out. So standard deviation is this formula here, and it looks scary, but I'm going to explain it so you guys can understand that it's actually not that bad. Just some notation. This S, this whole kind of weird looking symbol here, is basically saying that we're summing or adding all our data points. So that's all that's saying. We're going to add this to this to this, so on and so forth. XI refers to an individual data point. This is XI, that's XI plus 1, XI plus 2, so on and so forth, right? It's just listing each data point. So far, we're summing each individual data point, and we've got a negative here, so put the summing on pause for the moment. What's in these brackets here is xi minus x bar. This is what we call x bar. X bar is the average. So what we're doing is we've computed the average, and standard deviation tells us the average distance away each data point is from the average. Very confusing, but I'll make it clear in a second. So we're subtracting our data point from the mean, our data point from the average, which gives us the distance it is from the average, and we're just going to sum up all those distances and find the average of them. Nice analogy, I don't know if I've spoken to you guys about it before, it's the whole dartboard example. If I were to throw darts, why is this picture so big? Come on, car. Yeah, here we go. If I were to throw darts, right, say 3 darts, xi minus x bar is simply the distance xi is, or a dart, is from the average, assuming the bullseye is the average. That difference there, that distance, is xi minus x bar. Long story short, standard deviation is the average distances, or the average distance each data point is from the mean. So you take this distance, add it to this distance, say if there's a dart all the way over here, you find that distance, and when you do that for all your data points, you find the average distance each data is from the mean. That is our standard deviation, obviously very helpful for our task. So yeah, I think I might pause it there. Hopefully that wasn't too long. Where do I pause? Stop recording. See you guys.